So we will solve this question. So we will solve this question, the nth root of a number. So basically what we have given, we have two numbers n and m. Find the nth root of m. The nth root of m is defined as a number x such that when x is raised to the power n is it equals m if the nth root is not an integer return -1. Okay, so we have an over here example like n equals to 3, m is 27, output had 3, cube root of 27 is equal to 3. So basically we have to return the cube root. So basically we have to return the root of this particular number whichever we have given, and we have to consider this n value, whatever the nth value root of this m, we have to return. Okay, so first I can think about it. So first I can think about it like, okay, I will have this m number, then I have to figure out the nth root of this particular number. So basically I have to check that this m number is the nth root of the n. So what I can think of, like if I am at a digit 1, I will try to multiply digit 3 times 1 cross 1, so this gives me 1. Similarly I do for 2 and 3 and 4. At some point at 3 into 3 into 3 I will figure out this particular m is a nth root of that nth root. And so at particular point I will figure out that this m is a nth root of this given number. So the idea is simple. I will do a linear iteration on the range of suppose 1 and this is 27, whatever the m is given from 1 to m, and every time I will check for that particular number. Suppose I am at 1, I will check on the first number, does multiplying that particular number n times gives me this result or not, and I will do till my range is valid. So first thought is multiply. So first thought is multiply the nth times so my first thought is multiply the nth times number on a given range which is here m. Okay, then we'll figure out after multiplying nth times that particular range will give me this result or not. So we will do so we will directly write the code for this. This is a basically linear search. So this is basically a linear search. So let's do it. Now we are here like on the SD sheet of Striver. We will code it and see how does it work. So first I discussed about the range. So first the thought is to write the range from 1 to 1 is less than equals to given m. So 1 is basically like there is no point starting from 0, which is eventually a 0. So we took a 1 over here. So here we have defined the range, and now like I have to check that first this particular number multiplying n times, does it give me the mth value or not. So for that we can have a function, this dot find mth root. I can define the thing now for name of function like that, find the nth root, and here I will pass my ith value, and I will also pass my n value, whatever it is. So here we have. So after that what will I do? After this we have to calculate that particular number is a nth root of this particular m. So for this I quickly write the function for this, where I have I is as a base and n is my exponential over here. So this is the function which will tell me this particular number is my answer or not. So after doing this, I'll check once, like I'll check once if my given returned answer, if my given returned answer is equals to basically it will return me some answer. Let answer. Okay. Like first we'll write this function. Okay, this is base and this is exponential. Let's call let base, let's answer which will hold the end value, and we'll write the function to calculate the result, like calculate the nth root of this m. So we have an exponential over here, so we will do this while loop until exponential is greater than 0. Okay, so there is two case. If my exponential modulus 2 is equals to 1, so basically here my exponential is basically here um, uh, odd value. So in that case, what I will do in odd value, I just uh, reduce the count of my exponential and took one value from the exponential. So suppose this 2 raised to the power is 13, so here it will be a 2, so here it will be a 2 will extract it and left with 2 raised to the power 12. So it is like that. So here exponential we have minus, then we'll add that particular extracted value in our answer uh, into and answer into base, like whatever we are carrying the base. This is our ith. So this is base, our like whatever the base we are carrying, the basically ith value. Okay, now we are done with the odd number, and if it's even number of exponential, then what you do, you basically do the half of it. Exponential divided by 2, and what you do after taking a half, like your base will be base into base. So basically if you are given a 2 raised to the power 4 or 8, so what will happen is, like you will have this like 2 cross 2 cross 2. So you will have this, just a second. So you will have this 6, and yeah, you will have this. Okay, so you have 8 2, then this means like, so you can write it like this, all this way also, like 4 as a 4, then 4. Okay. So you can write this like this as this value, like if you have if you do a pair of this and this, so basically it's like 4 raised 4, this you can write like this. So it's basically 4 raised to the power 4, so basically a square, like half of the base. So you can do this. So this is the logic over here. So after doing these things, we will, what we'll do after, when the loop is over, we will simply return ans. Okay, we will simply return the ans. So now when you return the ans, let's store let value over here, and then after it's returning the some value, what we'll check, we will check the returned value. uh, the returned value is actually matching the m, because this value is basically after doing this ans into base into base, it will answer will have a hold of the exponential nth value, exponential nth value. So what will happen over here, if value is equals to m, if it is equals to m, then we find our answer return I. Okay, return I. We find our answer if at any chance, um, if at any chance, if just a second. Okay, then return the answer if you find it. um if we also check, like if the value is increased the m, so return -1. So basically, let's test it out. Okay, what is it? Okay, we just have to log in. Okay, just log in. Okay, how do I log in? Let's do it. So yeah, we logged in. Let's check it. Okay, okay, let's select over here JavaScript and paste it. Okay. Hmm. Okay, I'll do one thing. I'll just copy this code and simply cut it, and we'll have JavaScript and just reload it. Okay, what will it is doing? Reset. Let's do a reset. Okay, now this is the thing. Okay, let's do one thing. Okay, let n int nm int nm. Okay, nm, small nm, small nm. Okay, this is the thing and what it is. Over here, this is the function. Okay, fine. Remove this. Fine. If m n, over here it should be m. Okay. Okay, this got accepted. So let's try to submit this. What is it? Upgrade to submit. Okay. So we have to upgrade to submit it. Let's go to our profile which we have access. So here we have, let's write, paste the code here. Let's run it. So let's submit it. Okay, we got the TLE. Okay, that is accepted. So basically this answer got TLE. Let me check if we get the TLE. Did we get a TLE on bad implementation, or does we get the TLE on based on actually TLE it is? So let's check it out one more time. Okay, okay, great, we got the TLE. So basically our implementation was correct. It's TLE over here. Okay, now we have improved the, so we have done the brute solution. So this is our brute solution. So over here the time complexity is, we are iterating the loop over here which is m, and binary access is taking a big of log n. So basically the time complexity over here is m to iterate the loop, and here, and to find a binary is big of log n. Big of log n, basically on the search space we are finding the perfect n value, which is will we end up at the we are end up this number. So this is the question. So let's try to submit. So let's try to submit for the